Please welcome SAP NS2 CTO Kyle Rice.
Good morning. Thank you for coming to our Data Fabric breakout. Got a great session planned for you, so let me bring our panelists out here. First, we have Bob Palmer. He's our Director of Software Solution Strategy. Then we have Brendan McCord. He was the founding architect of the Jake. And finally, we have Bob Work, who's the 32nd Deputy Secretary of Defense. All right, so for the next 40 minutes or so, let me give you a little rundown of what we're going to do. We'll start off, I'll provide a little overview of what a data fabric is and some definitions there. And then most of the session will be based around customer success stories. So for those, what we'll do is we'll start with Bob Palmer, who will provide some basically 3 different stories of customers who are using data fabrics and having good successes with that. And then Brendan and Secretary Work will provide amplifying comments and information to kind of route that into the cause of the mission. So to start, what is a data fabric? I've got a Forrester definition here, so let me just read that to get us started. So to orchestrate disparate data sources intelligently and securely in a self-service manner, leveraging data platforms to deliver a unified, trusted, and comprehensive view of data across the enterprise. So that's a good definition. There's lots of terms that sound like they fit that as well. We've got a few of them up here on the slide. On the top there's things that are either similar or exactly the same as data fabrics. That's all good. Kind of putting the terminology aside, the key piece here is really a mindset change. You want to treat your data as the enterprise asset. This is the part of your enterprise that has permanence. By contrast, the things that use that data, the applications, the user experiences, the technology that leverages that data, that's the part that's going to evolve. That's the part that's going to change. That's the part that's going to migrate over time. So the key is focus in on the data because that's the part that really is relevant and permanent. So implementation-wise, there's kind of many permutations of what this can mean. For some data sources, you're going to pull them into your data fabric. Some data you're going to reach out to from the fabric. Some data is not actually going to exist anywhere. It's just going to pass by and it's streaming data. So you just have cognizance of it, but you're not really storing it. Data fabrics exist in the cloud. Data fabrics exist on-prem. Data fabrics exist in a mixed mode situation as well. But the key, really the key across all this is what you end up with is semantic as well as technical understanding of your data. You understand what it is, you understand where it is, and you understand how to access it both securely and efficiently. Those are really the key value props that you get out of that. So what we're going to be talking about today is some of the results that come when you implement a data fabric correctly. So you'll hear stories about how you can facilitate rapid technology integration. We'll talk about how you can do continuous innovation, including, in particular, artificial intelligence. You'll talk about how you can apply reliable governance and security onto your data environments. And finally, somewhat counterintuitively, we'll also talk about how you can get much richer user experiences and applications out of this. So that'll be the crux of what we're talking about. So before I turn it over, just one more definition piece. We'll use the term AI or artificial intelligence today. In that, we're actually talking about a fairly broad scope of technologies. We're talking about AI, we're talking about machine learning, we're talking about data science. We're not really disambiguating between those for our purposes, because at the data fabric level, those really, you can address all that the same way. So what I'd like to do at this point is turn it over to Secretary Work to say a few words to get us started with set some context for the discussion.
Well, good morning, everybody. It's great to be here. I'd like to start by saying the most important thing, hashtag finish the fight. So go Nats. I want to start 80 years ago, nearly 80 years ago. Nazi Germany had overwhelmed the Allies on the continent of Europe, and the last state that really stood in its way was Great Britain. And the last line of defense for Great Britain, standing from the Nazi war machine, was the Royal Air Force. Now, I think everybody knows the story about the Battle of Britain. The Royal Air Force gave the Luftwaffe everything they could handle and more. But it also gave us a glimpse of what would come. Because a lot of people know about the bravery of the pilots, and they know that the Spitfire and the Messerschmitt and all of that. But a little known story was the Dowding system. This was the key to winning the Battle of Britain. Hugh Dowding was the commander-in-chief of Fighter Command, and what he developed was the first recognizably modern battle network. Every battle network after this one had the same 4 general components. The first was a sensor grid that sensed the battle space and tried to make sense of what was happening. And in this, it's up at the top. It's radar systems and observers with binoculars calling in to what was then called the filter center at Bentley Priori. Now, the filter center is what we would call today a C3I grid, a command, control, communications, and intelligence grid. And it tried to make sense out of the chaos of data, just as Kyle talked about. And what came out of here was a delicious term. I just love this term. It was called the recognized air picture. And this was what everyone said, this is what we think is happening, and this will be the picture that synchronizes all of our efforts. And the red lines, it's hard to see probably, but it's pushing the recognized air picture out to all of the effectors, the effects grid, the fighter command units, the Spitfires and the Hurricanes, to the anti-aircraft gunners, to the barrage balloon specialists, to electronic warfare specialists, the ones who would actually apply effects against the Luftwaffe. Not shown here was the sustainment and regeneration grid, which would allow you to continue to operate under sustained combat operations. Now, the thing that put all this together was a data fabric. It was the means by which you could weave this tapestry and allow a recognized air picture which allowed decentralized, synchronized action. And so it gave truth that everyone could see, or it was at least the recognized truth, and it synchronized the entire place. Now fast forward 50 years, and in 1990, the United States and its allies, but generally the United States military, had a defining battle of a new revolutionary machine which was built around battle networks like this that could sense an entire theater and guided munitions, conventional guided munitions. And it allowed us to look deep, shoot deep, and kill deep, to actually really start to kill the enemy before they could even bring their forces to bear. It's what the Chinese called informationalized warfare. And the United States demonstrated this. The Soviet Union soon disappeared, the only competitor we had. And for 20 years, the United States military kind of had the run of the place, because none of the regional powers that we could face could duplicate this type of warfare, battle networks and guided munition warfare at the scale the Joint Force could. But by 2012, the Department of Defense was saying, hey, the Chinese and the Russians are catching up. The Chinese call their battle networks operational systems. The Russians call them reconnaissance strike complexes. And so the Department of Defense started saying, what happens when they can look, shoot, and kill deep as good as we can? It's not a pretty picture. For a power projection nation, moving into a theater, they created what we call anti-access and area denial networks. And in 2012, Ash Carter, who was the Undersecretary of Defense for AT&L, stands up the SCO, the Strategic Capabilities Office, and says, I don't like what I'm seeing in the Western Pacific. I need an organization that can start to bend the technological trend lines. 2 years later, Secretary Hagel announced the Defense Innovation Initiative, which said the department has got to get busy on this. We see parity coming. Parity is not good. So we've got to really start to think about how we're going to do things differently. And we conceived of an entirely new form of warfare, which we called algorithmic warfare. And it was enabled by a shift from what was called by DARPA handcrafted expert AI systems to statistical machine learning systems, which would allow us to do autonomy in virtually in software, in predictive maintenance, in course of action development, in predicting what might happen on the battlefield, as well as autonomy in motion with unmanned systems, robotics, etc. The Chinese called this shift from informationalized warfare to intelligentized warfare. And the thing, again, that drives it all together is a data fabric. Data that feeds all of our different algorithms, provides the force with the recognized common operational picture. It's, again, the fabric that weaves the tapestry together. So these unified data layers, whatever you want to call them, essentially need to have three big things, and we're going to talk about them in just a second. Standardization of your data, data at scale, and finally, data at speed. And those are the three different types of examples we want to provide you this morning.
All right, thank you, Secretary. At this point, let me turn it over to Bob Palmer to dig into some use cases I think we'll find simply irresistible.
Thanks, Kyle. I get the Robert Palmer illusion. Jeez. That's my whole life. So, all right, let's take a look at three examples of data fabric in action. The first two I'm going to talk about are commercial. Of course, the goal we might have by talking about commercial use cases is to understand how the commercial world and commercial off-the-shelf software may be applicable dual use to helping to achieve the missions of national security and protecting the homeland. The first one is Exxon Mobile. It's about data governance policy and access control for a worldwide distributed data fabric. Now, in the corporate world, mergers and acquisitions can drive the need to integrate data. And then for a worldwide organization like Exxon, many data operating units have separate data stores of their own. They have two broad categories of business process. One is called upstream, which is exploration and drilling, and then there's downstream, which is refining and chemical production. I would argue in the federal world, this is similar to the need for data integration between sister agencies that are pursuing similar missions. Or one could say that the Department of Homeland Security's many components have a data integration need. So there's some, I feel, parallel here. The Y slide, now this is their slide that they used at our user conference. And they have the Y for their data fabric strategy is to have global cross-functional system agnostic data ownership. So the functional owner of data is not dependent on who owns the infrastructure on which that data resides, is their concept. The root cause of data issues have to be found, discovered, and addressed at the source where the data lives, not moved over the network first and then remediated. They wanted a global standardized view of data. This is the hard problem of semantic interoperability for organizations as distributed as Exxon. A data fabric can help address that issue. And then they wanted to be able to measure the data environment. You can't manage what you don't measure, so they wanted rules definition, targets establishment, and quality monitoring of the data fabric. Now, it's important to note that this data strategy that they implemented is not to bring all of the worldwide data into a new Big Bang single repository. It's about access to the data in situ, so they can have a common semantic view, but the data still lives in the distributed environment. And most importantly, they have to be able to have the ability to build flexible data pipelines to use the data in many different use cases for many different consumers of data. So here's their how slide. The data fabric is powered by an SAP technology called SAP Data Hub. It sources data from structured databases, social media data, text-based documents, streaming geospatial data, which we would call ISR data, sensor data, Internet of Things type data, RFID tags, and many file systems such as the Hadoop distributed file system. Their goal was performance. They want to be able to handle queries on big data quickly using push-down processing. So push-down processing is leveraging the existing investments that have been made in data storage and data processing by, where possible, instead of bringing the data to a centralized place for processing analysis, to do what processing is possible down where the data already exists. This minimizes movement of data over the network to execute the mission. They wanted agility to rapidly build brand new data pipelines for new business use cases. They want to be able to expand it to grow data storage and process data where it's needed. They had to integrate the data from many different operating units with semantic interoperability. In other words, they had to make sure the meaning of one term in one data store was somehow translatable to a different language meaning for that similar data object in a different data store. And of course, usability. They have to deliver this great data fabric and data pipelines to a multiplicity of different front-end analysis tools. And by the way, this strategy is about empowering analysis tools and processes that are already existent in the environment. So this allows you to have a data fabric that is usable by many different front-end use cases and tools that the users are already comfortable with. So now I'd ask Brendan, in your experience in the JAIC and in the DoD, do you think that this commercial example might have some applicability to our federal clients?
Thanks. So I'm Brendan McCord, as Kyle mentioned, and first would just like to thank folks for being here. It's an honor to be here with you, Mr. Work, and the rest of the team in the audience. I'd like to, in reacting to these case studies, sort of do two things. One is draw an analogy between what's been learned in industry and what's applicable in the department and in the IC, and also connect this discussion to the direction and the concept for the crucially important work that's happening in the Joint AI Center, Defense Innovation Unit, and DoD AI strategy in particular. So first, oil and gas. I think you hit on this, but in oil and gas, you put IT down drill wells. You operate in austere environments around the world, even subsea environments. And as Bob said, these companies are formed through regional sort of M&A activities. So there are many different redundant IT systems. And you don't get to start from scratch. You sort of inherit these IT systems. So this is a wonderful analogy for the Department of Defense. And I think it's no surprise that DoD CIO Dana Deasy's background comes from a peer company to Exxon Mobile, which is BP. You talked about the combination of technology and process, governance, security, so forth, that enables what you called a global standardized view of data. And I think a key concept to key in on here is standardization. Bob mentioned this as well. In 2019, the reality is that the gap between what is possible at the frontier in AI and what is actually in use in enterprises, whether in the private sector or public, is large and growing. The gap between what's possible and what's actually in use is large and growing. Why is this the case? If you consider this sort of enterprise journey that many folks go on, first, they realize that AI or data-intensive applications generally could impact every corner of their operation. And so pilot projects begin. And these pilot projects have their own way of managing data, managing development, fielding, acquiring data, testing. On every dimension that matters, they're globally unique. They're snowflakes in the software sense. If you zoom out to the enterprise and you put together all of these globally unique projects, you have a terrifically complex problem on your hands. You have low speed, high cost, and if you're outside looking in, meaning you're a commercial vendor trying to scale their solution in the Department of Defense, good luck. It's a risk proposition because of this lack of standardization. You compare this to, say, the iPhone, the billion iPhones that exist today. It's highly standardized. And thus, the iterations and the improvements on that are orders of magnitude faster. You integrate that over time, and it's a staggering difference in what you're able to do because of having this unified fabric, because of having this standardization. So I key in on this because I think this is a crucially important mechanism for making progress here and for closing the gap between what's possible and what's actually in use in DoD and IC.
Thanks, Brendan. All right, let's look at another commercial example before we delve into our mission-focused solutions from NS2. This one is Walmart, and they have an application they call the Data Cafe. Its purpose is customer behavior analysis. Now, the concept here is the idea of taking data science from a laboratory project to a factory, a data science factory, to productionize data science and make it accessible to the non-mathematician, non-data scientist, business analyst. It's also a story about large-scale data, which you'll see, and very fast analytical processing on big data. So here's their house slide. They have 200 data streams in this application. They have meteorological weather data, they have economic data, they have Nielsen data, telecommunications, social media, gasoline price data, and local events databases. It's 40 petabytes, which is 250 billion point-of-sale records, and 3 million new records coming in per minute to the system. They have 5,000 users in the Walmart ecosystem querying this application simultaneously. The environment is the Hadoop distributed file system, Spark, Hive, SAP HANA, and for visualization they use Tableau. The results of this architecture is their queries run in 2 seconds or less. That was their benchmark. They use geospatial analysis, predictive machine learning, artificial intelligence algorithms, text analysis, natural language processing text analysis, and that's powered by the in-memory processing engines of the SAP HANA platform. Benefit was they had a massive data compression and a reduction in resources needed to administer the system. Now, here's their why slide. In their own words, the senior statistical analyst, Naveen Petamel, says, anything within these vast and varied data sets could hold the key to the solution to a particular problem. And Walmart's algorithms are designed to blaze through them in microseconds to come up with real-time solutions. And their CIO, Karenan Terrell, says, Data Cafe allows us to analyze the performance of East Coast stores on Black Friday and make pricing adjustments for stores on the West Coast before they even open. So that's a powerful business use case for big data analysis in a data fabric strategy. So I'd ask Brendan now, does that have any applicability to our federal customers?
Bob, I think it's another apt analogy, if a little aspirational, given the amount of data and the number of concurrent users. So Walmart is in some sense, a global logistics organization, and it's one that has instrumented its operations worldwide in such a way that it's able to sense demand and understand transactions that are taking place. It can do that, and then it can act on data in real time to send teddy bears into one location and toilet paper to another. It can tick its prices up and down to achieve its specific business objectives. So, by way of analogy, the military is in some sense a global logistics operation with pointy things at the end. And this sort of called to mind for me a conversation or a series of conversations I had in 2017 with General Dunford and General Selva. General Selva understands this problem acutely. In a prior life, he dealt with both the top-level strategy all the way down to individual, shipments of ammunition. General Dunford was charged with, in his role as chairman, global integration of forces and flow of forces worldwide. And so both, I think, saw the analogy to what had happened in industry and how folks like Walmart operate their global logistics systems, and just how much we needed to do in the Department of Defense to pull that into our unique context. So in Walmart's case, this is driven by a need to shrink the decision timeline from weeks or days to minutes or seconds. And I would argue in areas like wargaming and operational planning, it's necessary in DoD to really shrink the timeline from months to days to be able to make those decisions globally. Bob has a wonderful article on revitalizing wargaming from 2015 in War on the Rocks, if you haven't seen it, that talks about the need for rebuilding our sort of analytical wargaming operation. And I have to believe that models such as Data Cafe are a wonderful analogy for that.
Super. Okay, so let's now delve into some mission use cases as delivered by NS2 for the data fabric concept. We've reviewed some commercial examples of technology enabling a unified data fabric. Several of what I'm about to describe to you of these applications are already in deployment. Some are initial operating capability level or proofs of concept. And by the way, several of these, which I'll describe, you can see out in the hall in our NS2 Labs kiosks. Now, others I'll describe in somewhat oblique language, but if we want to have a discussion at a different venue, we can make introductions for government-to-government conversations about some of these applications. The first is battlefield intelligence and targeting. This is about ingesting message traffic and deduplicating those messages so that it's understood that this is multiple messages referring to the same adversary unit, not separate sightings of many adversary units. And all that has to occur in an automated fashion. It parses that message traffic using natural language processing powered by the SAP text analysis software technology. It also does machine learning, artificial intelligence, predictive analysis of possible future tracks of an adversary unit based on terrain and the type of the unit. And also things like weather could be used as a variable in that predictive analysis. That's powered by an SAP technology called the Predictive Analysis Library. Clients told us that the targeting tasks, which formerly took 20 minutes to accomplish, could now be done in mere seconds with this application. The second mission application for data fabric strategy is one you can see out in our kiosk. It's called Maritime Domain Awareness. This data fabric connects to streaming data sources from radar into historical databases, both. So it does three things. Vessel proximity assessment. Are two vessels rendezvousing, perhaps to pass illicit cargo between them? Or is an aircraft rendezvousing with a surface-going vessel? It does dark vessel identification. That is, ships that are not pinging the AIS system, which suggests they may be up to illicit activities. And finally, it allows pattern of life analysis so that you can understand which types of vessels are normally in which positions to identify anomalous behavior. We also have used the data fabric strategy to deliver an intelligence analysis platform. So the goal of this data fabric is to respond to information requests as quickly as possible. It can perform tipping and queuing to suggest other documents based on the analyst's search results for their query. So not other documents based on what they asked, but other documents based on entity types that are present in the results of their search in order to tip and queue for them to look at documents which they weren't even looking for. Then we have an application we call space situational awareness. This data fabric is used to compute satellite tracks in a high-performance in-memory environment powered by SAP HANA. So this thing tracks 16,000 satellite tracks, and some pretty heavy lifting mathematics have to occur in order to understand collision avoidance for all that stuff up there. Then we have an application we call continuous evaluation. And this is about insider risk assessment for users of cloud users. And this looks at 20 petabytes of historical data and 2 terabytes of streaming data every day. And the idea here is to use artificial intelligence, machine learning algorithms to understand anomalous behavior by otherwise certified users of a system. And then we have an application called the Analysis Data Fabric, which is about large-scale streaming data collection and authentication. So it's about understanding the data provenance, the metadata, the data about the data, and inserting governance policy on that large-scale streaming data, delivered to very many consuming applications, different applications. And crucially, this fabric has to be able to allow access to the original data source. So once the analysis process performs sense-making, very often the analyst wants to see, now I want to see the original source of this data before this goes to dissemination. So let's review the value proposition for these mission-driven, data-centric data fabric applications. For this, I would argue that quick time to value is an important value. For the maritime domain awareness application, we went to initial operating capability level in only 8 weeks. For the battlefield intelligence and targeting, that application was 2 full-time equivalent personnel in just 30 days for the first release of that. Space situational awareness was 1 FTE. It took about 4 weeks. The Analysis Data Fabric brought on a new domain with 12 new data sources in just 3 weeks. And the Unified Intelligence Fabric was 12 weeks for the first release. So the idea here is that from the initial requirement, the mission need to deliver a usable solution is powered by a flexible, agile data fabric. And I'd ask Brendan to comment on that.
Thanks. So Bob, I have 2 takeaways from this last section. One is you talked about mission impact. And rather than technology for technology's sake, the critical thing here is translating the technology into decisions and impact and changing the way we fight because of it. The second is speed. This last slide brings that home, I think. If there's one variable that we're solving for in the Department of Defense and in the IC, it's speed. The central logic of the AI strategy, the DoD AI strategy, is that in order to meet the national defense strategy and ultimately to preserve the peace, we have to translate the technology into decisions and impact. We have to do it at the scale of the enterprise and at the pace of technology advancement. Today, we're not organized to be able to do that effectively. That was sort of the central premise of the DoD AI strategy, and a whole host of things flowed from that. I learned a lot about speed for projects like this in my time in government, starting with a project that Bob catalyzed and launched, which was Project Maven. So I wanted to share 3 things that I learned about achieving speed in that context. The first is, sort of how do you deliver an outcome like this at speed for a difficult problem? Well, it turns out it's very similar to how you do it in industry and to how we've done it in decades past in national security when it's mattered. And that is having a small team with a specific problem to solve that is working directly with their end user and prioritizing shipment date. A team that has the discipline to start small and to deliver something and then iterate on that something again and again and again, and to scale that until eventually the entire mission area is transformed. The second thing I learned about speed is the importance of the folks you have on the team. And I think we have a mixture of those folks in the room here today. 3 key personas were there for us. One was the folks who intimately understand the mission context. Another was their technical peers who understand how to operate very advanced technologies, how to deliver and develop very advanced technologies. And the third is experts in really the points of friction, which include legal, acquisition, information assurance, all the things that folks are very familiar with. And it's a great thing to have them on, those areas of expertise exist in the same person in some cases, and I think you get that with the NS2 team. So the second was the importance of the context of your team. The third thing was the need to be intensely iterative with these types of projects. So to not have a sequential delivery paradigm that moves from early research on to the next stage to production, but rather to field and to use the fielding activity to uncover more problems, push those back to research or engineering to industry and solve them, knock them down and move forward. That's the magic of, I think, commercial product development since the 1990s, and it's crucially important for efforts like this. So those things are all lessons that I took away from experience in DoD about speed, which again is the most critical variable we're solving for here. I want to just zoom out a little bit as I wrap my remarks, and that is to say that this conversation is happening in a pivotal moment for the Department of Defense and for the IC. It's an inflection point. One way it's an inflection point is that for the past 5 decades, DoD's focus on AI and on data-intensive applications, its focus on AI was really on enabling risky discovery and technology creation. And that work was nothing short of visionary for the past 5 decades. To say that it transformed technology would be to really understate the case. It transformed the world. The additional imperative that DoD has today is to translate the technology into decisions and impact in operations. And so that additional imperative is why I'm excited to be part of this conversation, why I think it's crucially important. The last thing I'll say is we're in the midst of this military and intelligence revolution, but you see in industry how this is key to economic competitiveness. It's key to economic competitiveness at the scale of our country. And lastly, it could have profound impacts for the future of democracy. So we can draw a thread from all of these case studies to those macro thoughts, and I think it'd be right to do so. So thank you.
Fantastic. So thank you, Brendan. Thank you, Bob. Appreciate the content and the excellent commentary. So what I'd like to do now is first we'll ask Secretary Work to kind of round things out and provide some kind of closing comments. It looks like we'll have time for a few questions after that. So there should be a microphone in the back there. Oh, microphone's right there. So think about those questions while Secretary Work is talking, and we'll probably have 2 or 3 minutes at the end. Sir.
The National Security Strategy and the National Defense Strategy have said that the central challenge facing the United States is now a long-term strategic competition with great powers. In fact, the National Security Strategy refers to them as revisionist powers, a resurgent Russia and a rising China. And a lot of Americans say, well, what's the big deal? What does this competition have to do with me? Well, the United States has never faced a competitor since 1886 that has had a GDP greater than 40% of its own. At the height of the Cold War, the Soviet Union was about 40% of US GDP, and even in World War II, when Japan and Germany were combined, was just a little over 40%. China, the most pressing strategic competitor the United States will ever face, passed us in purchasing power parity at around 2014, 2015, and if projections stay along the lines generally they're going now, they'll surpass the United States in GDP in absolute terms by maybe 2025, 2026, 2028. Not only that, but they are what Vice President Pence calls a high-tech authoritarian regime. Throughout the Cold War, we faced the Soviet Union. They could compete with us technologically in niche areas like nuclear weapons and space, but their broad technological base was really far, far, far behind the U.S. innovation base and it allowed us to win the Cold War on terms favorable to the United States and our allies. The Chinese are a totally different kettle of fish. They are as innovative as the United States, and they are absolutely intent on never having to deal with what they refer to as a technological hegemon. And they have plans, national plans, to surpass the United States in the 2030 to 2040, 2045 timeframe as far as the best technological innovation power in the world. And the reason why that's important to all Americans is technology reflects the values of the political system that it is serving. In the United States, data, we worry about privacy, we worry about data provenance, we worry about how it will be used, we worry about the ethics, we worry about the legal and moral norms of how we're going to use this. That is all absent in an authoritarian regime that generally sees this as a means by which to maintain power. And we do not want a world. We fought the Cold War to make the world safe for democracy. Russia and China are trying to make the world safe and prosperous for authoritarian regimes. And no American citizen should want to face a world in which we are going head to head with a competitor with an economy that's bigger than our own and as every bit as good technologically. And the Chinese have said AI, artificial intelligence, will be the thing that makes this competition end in their favor. They believe it will increase their economic potential by at least 26% by 2030, and they think it will allow them to leapfrog the United States militarily. So the AI competition that is happening globally is important to everyone in this room and the companies that you represent, as well as all the Americans that we all serve. Now, AI has a stack. It's just this integrated technical blocks. There's talent, there's data, there's hardware, algorithms, and applications. We've talked about data today, about how labeled and curated data feeds this new generation of machine learning algorithms that really are going to change our economy and the way we fight. But I can't echo Brendan's comments enough. This really is all about talent. Talent is the thing that gives me the greatest confidence that we can prevail in this long-term strategic competition. To all of you who come here today, I thank you because you're on the front lines of this competition. And it is a competition that the United States must win to provide a future that is hopeful and a future that will be conducive to better health care, to better agriculture, to better transportation, and to make sure that we have the military superiority we need to prevent a war from ever happening. So I want to thank you all again for coming today. Thank you for what you do for our country, and just say, God bless.
Thank you, sir. All right, so it looks like we have time for about one question if there's someone that wants to. All right, looks like we actually have
There's
zero.
someone back there.
Well, I'm actually getting the hook over here. Apparently we are actually, apologize, we'll have to catch your question later. So thank you all for coming in. If you've heard anything today that you want to learn more about or might be useful to your organization, please stop by the labs kiosks on the way out and we can fill you full information there. So thank you very much.